Okay. Hello, everyone, and today um, I would like to talk about clean coding because uh, we are about to end the semester, and you are writing projects for approximately every coding class, and um, after some time, you will face the issue of um, having a complex code where you cannot maintain easily. And uh, it's always better to be proactive and prevent the problem from occurring rather than trying to solve it after it happens. Clean coding is a set of principles that help developers um, write a maintainable code which everyone can understand. I sent you two industry standard books. I mean, they are known by many developers, and these two books are suggested by many developers also. One of them is named Clean Code, and the other one is named Clean Coder. We will talk about the book Clean Code today, but I also suggest the other book. Clean Code talks about the technical side of developing programs, and Clean Coder talks about relationships between um, team members. So Clean Coder basically um, tells you how you can communicate with your manager, your peer, marketing team, etc. Uh, it's it has some parts about making promises and keeping them. It suggests honesty, and if something is not deployable, uh, or if some product is not ready yet, Clean Coder says that you should communicate this with your um, department, with your team members, and have an alternative solution, etc. So this is why I suggest those kinds of things, because otherwise, uh, if you don't know your limits or your frame, if you don't know how you can, um, if you don't know what uh, you should do when communicating and what you should not do when communicating, then you will face many difficult scenarios. For instance, you will promise to develop a huge project in 1 week or something like that, and you will have sleepless nights trying to keep your word, but at the end um, you will have an unfinished or unmaintainable code, and you will be sleep deprived. And because of those, it's, like I said, better to give promises that's it's possible to keep. And book talks other topics as well, but that's basically it. And like I said, I suggest you to read that before you start your career. But today's topic is clean code, and I will share my screen and we will go over the book. And you will see how you can I mean, since you are kind of busy writing code these days, I believe it can be beneficial to you to refactor your code. By refactor, I mean rewriting some parts of your code so that it's easier to understand. So the book's full name is Clean Codes, a Handbook of Agile Software Craftsmanship. And the main author is Robert C. Martin, which is known as Uncle Bob in programming community. This author is quite famous. He's also the writer of Clean Coder book, which I talked about. And we will see, I mean, I will talk about, I mean, I will try to give you a summary of the book as much as I can. So it says that, the book says that, I mean, there will be code that you have to examine and rewrite, etc. And because of that, we will always need to check the codes in the book and in our project as well to make it, cleaner, etc. But some people might think that programmers won't be needed because business people will generate programs from specifications. Like, there's a website called wix.com, which you can create some simple websites, but you can say that, I mean, you can think about Facebook or Instagram.com, for instance. They are not generated by wix.com, obviously. I mean, wix.com is feasible for very simple websites, which does not track background information, etc. So because of that, we will always have jobs. We will always have projects to develop. So we should not be expecting that in the future we will write less code or something like that. Of course, there are increasing number of tools which help us. Unity is one example of that, but this doesn't mean that we should, expect to be jobless, or also we should not dream of lazier lifestyle. It's better that we should get used to writing code, and it's better that we should get used to writing it cleaner and as professional as we possibly can write. So what is bad code? Bad code is, according to this book, is the code that no one can understand, even you, after some time. And why do you write bad code? It's I mean, we haven't determined what is bad code, but I mean, there are some ways to sense what is a bad code. If you are thinking that the code you are looking is complex and messy, and when you change something unexpected happens, or you are cussing when you are looking at the code, then it's probably bad code. And the reason people write bad codes are because of the pressure in the company. So when your manager pressures you, you feel in a bad mood and write code that is in subpar quality, I mean below the quality standards. I mean, it's also not a big issue if you are trying to find a solution and writing a messy code, because after you find the solution, you can refactor the code, you can clean up the code to make it more understandable. But if you are leaving it at that point, and if you are jumping to another development topic, if you start developing something else, and if you are saying to your managers like, okay, this is done, this is finished, even when it's quite messy, then you are doing something wrong. Your peers will not be liking that, and also after some time, what you develop will have some issues, some bugs, and you will have to fix those bugs. I don't know, a couple of months later, where when you forgot about the code, and when you have no idea how to solve this bug, and you will spend hours of uh, weekend days, for instance. So you shouldn't do that. Um, and if you have a code like this, then your productivity, I mean, the productivity of your team gets reduced each week, each day, because code gets complex each day, and it becomes something that is not scalable. So you cannot scale it bigger. I mean, you cannot add to it until something. You cannot add something to existing code base without breaking another thing, and because of that, productivity goes towards zero. Okay. So let's talk about what is clean code. Let's see a couple of definitions. So this guy, which is inventor of C++, says that I like my code to be elegant and efficient. The logic should be straightforward to make it hard for bugs to hide. The dependencies minimal to ease maintenance. Error handling complete according to an articulated strategy, and performance close to optimal, so as not to tempt people to make the code messy with unprincipled optimizations. Clean code does one thing well, and it does only one thing. So clean code, I mean, if you choose a method, for instance, this method should do only one thing, but we will talk about this later when we're talking about methods. Okay, let's read another one from the author of Object-Oriented Analysis and Design with Applications. So clean code is simple and direct. Clean code reads like well-written prose. Clean code never obscures the designer's intent, but rather is full of crisp abstractions and straightforward lines of control. So we should talk about obscuring designer's intent and crisp abstractions. I mean, if you are the reader of the code, you should be able to understand what the author meant, okay? What the author's aim was. So this is what we mean by designer's intent. The method names should be clear and telling what this method is doing. The variable names should be clear and they should describe what the variable is, you know. So you don't write variables like a, b, you know, stuff like that. You don't write variables like ASDF because if you went out to drink a coffee and come back, then you will forget what this ASDF variable is holding, you know. So you don't write stuff like that. Okay, let's see another description. Clean code can be read and enhanced by a developer other than its original author. It has unit and acceptance tests. It has meaningful names. It provides one way rather than many ways for doing one thing. Okay, let's stop it at this point. So you don't write unnecessary code. This is what this means. If you have a way to achieve one thing, you don't add the second way of achieving the same thing, because this just increases the knowledge that the maintainer, the developer should know. Do you remember the code that we have written? You know, do you remember when we are moving objects, Unity has transform.right. Transform.right gives you a vector that is pointing towards the right part of the object, and there is no transform.left because you can easily generate this method by writing minus transform.right, right? So this is why, I mean, the principle behind this decision is keeping it simple, basically. Clean code has minimal dependencies, which are explicitly defined. So other guy also talked about dependency. Let's talk a little bit about that. I'm actually going to open up a board. Okay, can some of you just say a class that you are working on for your homework? Just say one class.
Basic programming, something like that.
Basic programming is the name of the class?
Yeah, basic programming C.
Okay. Now I have to ask you what this class does. But if you named it correctly, I shouldn't have to ask you, right? So what this class does, can you tell me about that?
We are learning C language, coding language.
No. By class, I mean the class in the program. You know, object-oriented.
Yeah.
Teoman. I mean, it can be any class name that you are working on.
In the code.
Yeah, in the code. I mean, just say one class that you have written. Just say the name.
Slash ready.
What?
Ready, like we are writing on this game starting screen, we are saying like ready first.
Okay, and you are
or main, maybe in main.
yeah, let's keep it simple. So there's a main class, right? And inside this main function, you have some other classes, right? So you have some variables in your main class, right? Some of them are integers, maybe, and some of them are other class members. So, for instance, do you? I mean, um, I'm trying to imagine how your programs look like, but for instance, what did you do with this main program? Do you remember what was the aim of the program? Uh, I mean, maybe you have a collector of numbers, right? What I mean, just say me one project that you have worked on. What did it do? It doesn't
I
even
mean,
have.
in general, we are coding some games, so I will be saying player or something like that.
Okay, okay. So there's a player class, right? In general, and let's call this game controller, okay? And this holds player health, right? And um, when player health is below a point, then game over, right? So there should be a handle. Actually, let's write C# codes. Player, sorry, handle player, sorry, handle game over method. Okay, so we have a method like this, and we have a player health which is an integer. Okay, so you see where I'm going with this. Let's me just enlarge this. Okay, so we have a game controller class that has a reference to the player. Let me just edit this. Player scripts player, right? And it has an integer value which is player health, and it will have a function which we call reduce player health, right? And it will have a function which is responsible for handling game over events, right? So this will be printing out game over. So let's just create a simple stuff. Let me just enlarge those. Okay. So, I mean, are you having trouble seeing the code, or let me just? Okay, you are easily understanding, right? Okay, nice. So, oh, let me just drag it like this. Okay. So, in this example, you are referencing from game controller to player script. This is a problem, actually. Maybe you haven't noticed it until this point. But if player script is changed or removed, then you have to edit this game controller. There are some ways to get rid of this dependency. One way of getting rid of this dependency is dynamically accessing player from the game controller. Okay, so you don't write uh, player scripts player like this at the start. You don't insert this player script right here. Instead, um, you do something like this. By the way, do you know about interfaces? Have you um, have you learned about interfaces? Interfaces in programming, by the way. Um,
No.
yes. No. Okay. Uh,
Maybe we, but can you give us an example
yeah. Okay.
about?
So interfaces start with the letter I. Okay. This is the general convention. So everybody writes interfaces like that to not get confused with classes. And interfaces uh, describe a behavior. Okay. They describe some um, methods. Okay, this will be hard. Uh, Let me just actually we have less than a minute, so I will give a 10 minutes break. Okay, just get some water, uh, wash your face, and we will talk about something that is kind of hard to understand at the first glance, but I hope we can manage that. So after 10 minutes, let's meet up again. Okay. We will talk about how to solve this dependency, basically. And I will show you some examples of that as well. So see you later.